In the following video, we're going to be examining how to identify linear functions. Now, linear functions, if we look at the first four letters of the word linear, we see it forms the word line. So linear functions are functions that one graph a straight line. Some of the tricks that you've been taught before, maybe for linear functions, is that if x has an exponent of 1, then it is linear. And that is true. But when we examine certain functions, you may think that there is an exponent of 1 when in fact there isn't. So you need to be careful. What a linear function is a line on a graph. It's a graph that's a straight line. The variable has an exponent of 1, and the variable needs to be in a way the numerator. Because if the variable is in the denominator, it's not an exponent of 1, and we'll look at that. So one way to check our answers is to look at our graphs if we input them in our calculator. The other way is to examine the function itself. So if we take a look, we have f of x equals 8 minus 3/4 x. And we're asked, is this a linear function? Now the basic format that you've learned before for linear functions is, hey, a line follows a rate of change. So you've learned slope-intercept form, y equals mx plus b. So one trick to help some of you is ask yourself the question, can we manipulate the equation to look like slope-intercept form? So if I take a look, f of x, remember that's just a fancy way of saying y equals. We have 8 minus 3/4 x. I could use the commutative property and switch the positions. So you get negative 3/4 x and a positive 8. Now if I ask myself, does this look like slope-intercept form? And it does. I have a slope of negative 3/4 and a y-intercept of 8. So is this a linear function? Yes. And the reason why here it is because we have a slope and a y-intercept. If I look at part B, f of x equals 2 over x, it does this follow my slope-intercept format. And what I would see here is this x is in the denominator. So really, that does not have an exponent of 1. It doesn't follow the idea of slope-intercept form. It doesn't follow the idea of a linear function. And so therefore, this is not a function. And the reason why is your variable is in the denominator. Now we can examine that this is not a linear function by looking at our graphing calculator. F of x is just a fancy way of saying y equals. So we go to our y equals for graphing, and it says 2 over x, so 2 divided by x. And if we go to the graph, we'll see it is not linear. There is a curve to it. And so therefore, this is not a linear function. Our graph has curves. So we can actually verify it as well with our calculator. So let's examine part C. F of xy equals 3xy minus 4. And these are the ones, like I said, you think to yourself, oh, look, my variable has an exponent of 1, so it has to be linear. And that's false because we actually have two variables. This function is defining your variables as x and y. And so therefore, this is not a function. We have a product of two variables here. And so therefore, it is not a function. Because we have this product of two variables and this function defines a different variable, we cannot input this in our calculator to determine graphically if it is linear or not, like we could in the other example. So you have to understand how to interpret functions from the form they're given to determine if they're linear or not, and be able to explain it without relying on the calculator. The calculator is there to assist you to verify your solution when you can, but there are moments where you actually have to apply the definition of linear functions.